right, this is question number 9 on the Honors Algebra 2 Day 2 homework of graphing. What's happening here is there's an amplitude change, a period change, and a vertical shift. So we're going to show you how to identify those and how to graph it. So the amplitude is always the number in the front of the trig function, but it's also the absolute value of it. So even though there's a -3 here, the amplitude is only 3, but I know it's going to be flipped upside down. So instead of being a regular sine graph, it's going up first, it's going to go down first. So there's the amplitude. The period, we're going to set this stuff in the parentheses. I added the parentheses in. They weren't in the problem already, but you can do that. And I'm going to set this equal to the normal period length, which is 2 pi. That's the normal distance. So set 1/2 theta equal to that, and we're going to solve for theta, which will tell us the new distance. So to get rid of 1/2, I'm going to times by 2 on both sides to keep it balanced. And so this is 4 pi now is our new distance. So that's the distance. Also, something to identify here is the vertical shift, which is +2. That's this number on the end. So that's also being asked on your paper. Amplitude, period, and vertical shift. So we're just going to draw a graph now of this. Let's go right here. Some room. We're going to start at 0. There's no phase shift yet. You don't know how to do that yet, but you will soon. So starting at 0, our distance we have to travel is this 4 pi. So from 0 plus 4 pi, that'll be 4 pi. And we're just going to find all the halfway marks now. 2 pi, 1 pi, 3 pi. Those are nice and easy. And I'm going to draw my regular sine graph first. So that starts at 0, then goes up, 0, then it goes down, 0. So again, notice we're doing sine. That's just a little thing to keep in mind. Okay. So next thing I'm going to tackle is the amplitude and then the vertical shift. I'm going to do them together though, because that's how we've been practicing in class. So we're going to multiply by the amplitude, and technically we're multiplying by -3, even though we only wrote 3 here. So we're going to multiply these y values by -3 and then move them up 2 more from where they end up being. So let me relabel some stuff here. So we're at 0 times -3 is still at 0, and then up 2. So it'll be a +2 there. 1 is the height times the -3, which will be at -3, 1, -1, -2, -3. So I'm really here, but now I'm going to add 2 to that. So I'm at -1. Okay. 0 times -3 is still 0 plus 2. -1 times -3 is +3, but then I'm going to also go up 2 from there. So really now I'm at 5. This is a 5 up here. And then 0 times -3 is 0, plus 2 more is up here. So this purple, hopefully you can see the difference. First of all, it's flipped upside down. It's also spread apart more this direction. Here's our midline, is at +2. And the distance between this top to the midline is a distance of 3. And same thing this direction as well. This is a distance of 3. So that's where that amplitude comes from. It's the distance between the top and the middle, or the bottom and the middle. And then it's been shifted up 2, so now the middle of it is at +2. So hopefully that helps with the period change, amplitude, and vertical shift all together.